So just delete that, right?
Um, yes, yeah, I think.
Okay, sure.
So far, so good
So far, so good. Oh, okay. And the project goal is how covariance metric apply to fixed income and make an estimation on covariance metric to find the order to reduce the error on metric, value the risk of company, and find the true covariance metric. So this is our agenda. The first we will introduce the background, and then second is the problem statement, and then the third is potential solutions, and the fourth is current result, and the final is next step. So start with the background. A covariance metric describe uh, the variable of co-movement. And a covariance metric is a table which each variable lists along both row and column ahead. A cell value in the table is the covariance matrix between the column and the row variable. And this is the example of the covariance matrix. And then it is important to fixed income because covariance matrix is a tool for conveying the information about co-movement of the bond. And then the return from security move with respect to one another allow portfolio manager to diversify the bond of holding or compound the return of a specific strategy. And the example is that in a period of extreme fluctuation, offset the loss by purchasing anti-correlate bond. It's the purpose of the building portfolio. And
let's take a step back to that last one. So you did a nice job of explaining it. But what might be some potential obstacles that would come up when putting covariance matrix for fixed income securities?
What are the
That might be something that you want to mention.
the obstacles?
Yeah, so like the illiquidity of bonds or comparing bonds of different duration to each other, just things like that.
Oh, okay.
Just to make it clear to the audience that estimating covariance matrix for fixed income securities isn't as straightforward as it is for equities.
Just as a side note, is it feasible to also mention that most of these concepts, including the covariance matrix, works more efficiently on equities instead of bonds?
Yeah, so that's a really good question. I think a good thing that you could talk about in your presentation is that not only covariance matrix estimation, but really the majority of quantitative finance techniques are really heavily researched in equities, but they're underdeveloped in fixed income because of things like we've talked about over the course of this project, like the different duration of bonds, the different credit risks of different bond sectors, the illiquidity of some bonds. That could be a really good talking point. Is like quantitative finance methods that aren't applied as much to fixed income as they should be. We're starting to bridge that gap in our project as the first step towards having a more quantitative focus.
Okay, all right. We'll make sure to include that.
Yeah, that's a really good idea. I'm glad you brought it up.
So the covariance metrics are used to mitigate the risk, and in portfolio optimization, we want to minimize the risk, which is the variance. And then in the index replication, we try to minimize the tracking error. So the problem statement for our project.
Hang on one second. Can we go back to the slide we were just on? So one more. There you go. So no, one forward. We're talking about tracking error. So does everyone have a good grasp
To minimize the tracking error is to reduce the gap between the index and the portfolio. Is that right?
Yep, yep, exactly right.
Yeah. So.
And so if you have an investor come to you and say, I want to match the returns of the index, so I want a passive fund, then minimizing tracking error should be your number one goal.
Yeah, exactly.
Yep, good.
So continue.
Okay, yep, we're good. I just wanted to make sure that if that comes up, you'll be ready for it.
Okay, sure. And because it is difficult to estimate the future covariance metric for multiple reasons, so the covariance between the bond and change frequently. And then second is that the estimate become unstable as the number of the bond grows. And then the third is the estimation become computational expensive with a large portfolio. And then the risk is the poorly information decision, and then it had come out with the bad estimation, and then too difficult to compute. And the good things is that good risk measurement, and then could give us the better diversification, and then the better optimization.
Okay, two things. The first one is that in the rewards category, you can add huge financial savings, because right now we pay for a risk metric. We pay for a couple risk metrics from Bloomberg and Aladdin. And so if we could develop a covariance matrix in-house that does a good job, that could save us hundreds of thousands of dollars. So that you could add that in the rewards box, because that's one that would get people's attention.
Oh, okay.
Then in the risks bucket, can your team think of anything else that might come along with having a bad covariance matrix? If you don't have an answer, that's fine. I can't think of any off the top of my head. I'm just trying to crowd
we can figure it out.
Should we also add additional transaction cost in addition to the poorly informed decisions?
Oh, yeah, that'd be a good one. So, yeah, if you have a bad covariance matrix that doesn't accurately convey the true co-movements of securities, then yeah, be paying transaction costs on top of making poorly informed trades. That's a good one.
So the potential solution of the problem is that the first things we will do the sampling to find the bond selection in order to build a sample. And this is how the process of how we are doing the sampling. And then we take
Can we go back to that slide? Go back to that slide for a second. I just want to read it. Okay, this is a pretty busy slide for the midpoint. I'm trying to think if there's a way you can make it a little bit simpler. Because I don't think your audience is going to care so much how you're ranking the bonds and everything. They'll care that you have a method for doing the selecting, for doing the bond selection.
okay.
But yeah, I'll give you some feedback on the slide. It's a good start. We just got to maybe cut down some of the details on it.
Okay.
So
Okay.
so we decided to use the S&P rating, and then yield to worth, and then also the OS and OAD, which is the efficient duration to select our model, to select our bonds. And for the average that we take from the index is that the OS is 475 points, and then the duration is 4.1 to 12 years, and then the S&P rating is 14.7, and yield towards is 6.52. So this is the average of the cell characteristics in the
For
index.
just one cell? For just one cell or for the entire index?
From 2011 to
To
2018.
2018.
Okay. So what is this slide telling me exactly? It's telling me the average of these characteristics and the index for 8 years.
Oh, this is just a sampler from the previous slides which the average you are taking, and then this shows the number that's the comparison, and then the method that we select.
Okay. Okay. I think I understand. It works for me. Good job.
Brody, is it a good idea to put in the numbers, the average characteristics? Or is it,
The average. No, go ahead. Go ahead.
no, I'm saying the cell characteristics average for the whole meeting. I'm curious to get your feedback. You said what are these numbers telling me, and that's not the question that, yeah.
It's still a little bit unclear to me because on the previous slide you're talking about the way you selected bonds based on these different categories, and then in this slide you're telling me the cell characteristics average.
Yeah,
I'm
so
not sure why.
yeah. Okay, so
I'm not sure.
go ahead.
Yeah, go ahead. Ted, I mean, it's not clear to me what this is conveying. It's telling me the average of the whole index across 8 years. It's telling me the average inside one cell, because how you have that one cube highlighted, it makes it seem like those are the average in one single cell.
Okay. So we're gonna change the cube then.
I like the idea of the cube to like kind of give a visual for the way you're separating the index into a bunch of different samples or a bunch of different buckets. It's just unclear what the relationship between that sampling method and then the overall average of the index is. So I'm not sure that you even need to tell me the average of the index across this time period. Maybe instead of that, just give me some examples of the averages inside a couple of the cells that you define.
Mm-hmm. Okay.
So you have like maybe 2 or 3 cells, and then the averages in those cells, so people kind of get an idea of the split.
Okay.
Does that make sense?
Yeah, it makes perfect sense. Noted.
Okay, great. That's a good idea, though. I think the cube is a good thing, conveys a lot of information.
So previously we were saying about how we select the bond, and then this is the first problem we need to solve, and then the second is we are going to use the sample covariance matrix estimation to figure out the MSE and the MAE, mean square error and the mean absolute error. So the good things for the sample covariance matrix is that we understand the risk between two assets and could provide the portfolio optimization and then maximize return, minimize the risk. And it is easier to compute. And finally, said the expect value is equal to the true covariance metric. The bad thing is for the sample covariance metrics that affected by the long-term series, which is the times longer, the covariance matrix could not be, the error will be increased. And then the second is that we are using the historical data to figure out the covariance metric. And then the third is there's a higher turnover. And the third is sensitivity of the outlier and also does not exhibit the dynamic structure of the market. And then the upper,
I think those are all good. What the higher turnover? What does that refer to exactly?
which is because as my understanding that mostly the portfolio will be adjusted uh, sooner if when the bond is meet the maturity. So sometimes the portfolio will be adjusted very fast. So which has the higher turnover of the sample covariance metrics.
Okay. Yeah, I'm not sure I followed that one because you would think in covariance matrix the bonds are going to stay similar, but you're saying the recommendation that the covariance matrix makes for the securities in your portfolio changes more frequently when using the sample covariance matrix. Is that what you're saying?
Yeah.
Okay. Yeah, if you can explain that, then that's fine to keep that in there, but that is kind of difficult to follow. Because when I see higher turnover, it makes me think like the bonds in the covariance matrix estimation are changing. I know that's not what you mean, but it's kind of what I immediately think of, and that doesn't make sense.
What would be?
That one maybe if there was, okay, go ahead, Cal.
I was just gonna say, what would be a better expression to explain that, just as an idea?
Yeah, so I would say something along the lines of suggest a more turbulent portfolio or incurs more trading in your portfolio, something like that.
Okay.
Just something that clearly links it to portfolio construction.
Okay. So and then we were also using the weight sample covariance metric, and which is a little bit better. And for the weight sample covariance metric, the definition is that the WT is the weight of observation at time t, and weight covariance compute the covariance when each data point may have the different weights. So the good things of this model is that allow us to give the weight to indicate the significance and the value of comparison. And the second is that could reduce the volatility. The third is the weighting recent observation more heavily than the recent one, which is the good things because when the time move, we will just ignore the the past data, which is longer has a longer time. And then the bad thing is that it's similar as the sample covariance metric. However, the difference they has with sample covariance metric has the weight variance. And then another bad thing is that estimator could be unbiased only if the weights are not standardized or normalized. And the final is that the results are affected by the method of weighting.
That's a good slide. The only thing that I would mention is that when you say reduce the volatility under the good things, again, you're going to want to say reduce the volatility of the portfolio or of the suggested portfolio.
Oh, okay.
Okay, this one's good. Has your team been able to implement the weighted sample covariance matrix estimate?
Brody, can you repeat that?
I said this is a good slide. Has your team been able to test the weighted sample covariance matrix estimation method?
The weighted, yeah.
Yeah, we can test it. You mean use the MAE or MSE, right? to test the performance, right?
Yeah, I was just asking if you've been able to implement it and have some results for me. I'm excited to see them if you do.
Yeah, we will show you the result in the next few slides.
Okay, great.
Yeah.
So the final method is that we are using the shrinkage estimator, and then which is the best and most complex. However, for now we're not finished the shrinkage estimator, but we will finish before the next week. So for the definition of shrinkage estimator is that this method combines two estimator, the sample covariance metric and the factor-based estimator, in order to achieve the optimal balance between the sample error and specific error. So the good things for the shrinkage is that mitigate the impact of estimation error in portfolio optimization and reduce the portfolio tracking error. And then the third one is more accurate when formula Sharpe ratio. However, the bad things that increase the standard deviation and still affect by the size. And final is that the error appear when population has optical mean.
Okay, so I have a couple questions on that, on the shrinkage-based estimators. So shrinkage estimation methods are, if you do them correctly, they're really difficult. So I don't want you to try to speed through those and have them done by the midpoint. It's okay if we work on that after the midpoint. Because you have to build your factor-based covariance matrix, and then you have to tune a hyperparameter for the weighting scheme between the sample covariance matrix and the factor-based covariance matrix. So it's a lot to pack into the next week. So I would rather you focus on the presentation and then put work on the shrinkage-based estimators off until after that point.
Okay.
Okay, sure.
I assume you guys are okay with that, because I know it's really difficult to do these methods.
Yeah, because we are discussing. Sorry?
Go ahead.
Oh, because we are discussing about.
Go ahead. I didn't mean to.
The shrinkage estimator has the package in R, so. Yeah, but yeah.
Can you send me that? You send me that package. I'm not familiar with it, and I know that estimating a factor-based covariance matrix is pretty difficult. So I'm not sure how a package in R is going to do that. So I'll have to look through the documentation to see if I think that's appropriate.
Okay, I will send you the package name and the document of the package. Because actually, we found two different packages that can do the shrinkage. The one is focused on the portfolio estimation, and another one is just the general shrinkage thing. So I think the two packages.
Is the shrinkage for covariance matrix estimation?
Yeah. The one of the shrinkage packages is about the portfolio estimation and the covariance matrix estimation.
Okay.
Yeah.
Do you know off the top of your head what factor-based covariance matrix they use in the shrinkage formula?
Yeah, I think so. I think that package can estimate the factor-based estimation in some way, but actually I still feel a little bit confused about that package, because I used to apply that package to our data, but the result is not that quite good. So that's why we haven't started yet.
Yeah, I'm skeptical about any open source package that implements the shrinkage-based estimator, because, like I said, they're really hard, and they're pretty new. Like, a lot of these papers are coming out in the last couple of years, so I'd be surprised to see a good implementation in R that's already out there. But yeah, send me the documentation for those packages, and I'll check them out, and
Okay, sure. Yeah, I will send you the documentation and the package to you.
Great.
Okay.
And so this the next will be the current result. That we also do the data visualization of the investment grade security, investment grade bond.
And Andrew
Okay,
will.
so the rest of your analysis is on high yield bonds, right?
Yeah, currently we are focusing on the high yield bond, but we also do the basic data visualization for the investment grade bond. We use Power BI to do both data sets. And this one is for the investment grade data. And next page, I think yeah.
Yeah, here. So we are concentrating.
Brody, you think it's a good idea to focus on the visualization of the high yield instead of for the presentation's sake? I just wanted to get your feedback.
Yeah, as long as you make it clear that eventually you're going to be implementing these methods on both the high yield and investment grade data, I think it's fine to show the summary of the investment grade set. But do make it clear that you're focused on the high yield data for now, and that after you get some working prototypes, you're going to try your methods on the investment grade.
Okay.
Okay.
Yeah, I'll leave it up to you whether you want to keep the investment grade summary slide in. It's fine if you do, it's fine if you don't.
Okay. The next is the
So this is for the high yield.
Yeah, this
data.
one is for the high yield visualization, summary, statistics.
Yeah, it's interesting to see the distribution of bonds by their index rating.
Mhm.
Yeah. Okay. And yeah, good job. I like this.
So we do the implementation of sample and weight sample estimation for now, and then future we will do the shrinkage estimator if we could. So for now we're done the sample coverage metric and weight sample coverage metric of the MSE and the MAE. These slides we will finish before
Midpoint.
Yeah, before the midpoint. So.
Yep. And team, I just want to point out something that I was actually just discussing with one of my team members this morning, and that's that the buffer of 1 month might not be large enough in this case because you have a lot of information leakage from the sample covariance matrix to the true covariance matrix. So I'm not asking you to do this by next week, but in like the second half of this project after the midpoint, we're probably going to want to expand that buffer to say 6 months. Because when you're calculating the covariance between two bonds, let's say, the number of data points that are the same from the sample covariance matrix to the true covariance matrix, if you only use a 1 month buffer, is like 34 out of 36. So that's just something to be aware of going forward. And just know that we will probably be expanding that buffer.
Okay.
Okay.
And that's on me. I should have realized that sooner, but it's fine. I think it's good for now.
Okay.
We use the rolling MSE and mean square error and mean absolute error to evaluate the result. And for the mean square error, the number is higher, the risk is higher, and then vice versa. However, the mean absolute, sorry? Oh,
I just said this is good. Yeah.
and for the mean absolute error, the sensitivity is not as higher as the mean square error. So for now, we only focus on mean absolute error for this presentation. But before the midterm, we'll finish the mean square error. So this is the sample covariance matrix estimation result of the mean absolute error.
So actually we because in the feedback from last week, you said that at least we need 100 bond as in our simple data set. But and you also want us to set the time duration from 2011 to 2018 instead of 2015 to 2018, right? So but when we
Yeah, if at all possible.
yeah, but when we check our data set, when we check our high yield data set, we realize that there are only about 70 bonds has the full observation, has the full information from that time period. So
Okay.
yeah,
That could be interesting.
yeah.
So I'm fine if you just use those 70 bonds, but you also might want to think of a way to keep that number 100 by adding and subtracting bonds.
Yeah.
Right.
Right. I will introduce what kind of method I have used for bond selection because you can see in this slide we divided the bonds into 6 different groups, and because there are 70 bonds has the full observation between 2011 and 2018. So I keep those 70 bonds in the whole time duration. And in the 2011 and 2013, I add 30 bonds, which have the full data. And then I replace those 30 bonds with another 30 bonds in the second time duration. And I use the same method to the other 4.
That's a good idea.
Yeah.
Yeah, that's a good idea. What is this table telling me?
Yeah, right. So I compute the MAE between the simple covariance matrix. For example, if we set the 2011 and 2013 as time t, then 2012 and 2014 as a time t plus 1, right? So we calculate the MAE between t and t plus 1 because the t plus 1 is the true covariance matrix.
Oh, okay. So the covariance matrix at time t are these, is the 70 bonds or is it 100 bonds?
100 bonds.
100 bonds, right?
Yeah, 100 bonds.
Okay, and then your covariance matrix at time t plus 1 is the covariance between bonds from 2012 to 2014.
Yeah.
And then you're comparing, okay, nice.
Yeah, so
there's a full year of observations in the covariance matrix from 2012 to 2014 that is not in 2011 2013, correct?
yeah, there are 30 bonds in 2012 and 2014. It's not in the 2011 and 2013. Yeah. So please continue.
My question is, so the covariance matrix from 2011 2013 is fit on data from 2011 to 2013, and then the next covariance matrix that you're comparing it to is from 2012 to 2014.
Right.
So all of the data from 2014 will be new data.
And
the covariance matrix from 2011 2013 is never seen before, right?
Not exactly, because we keep the 70 bonds in 2012 and in 2012 to 2014, and then also in 2013 and 2015. Every year we have like 70 bond, 80%, keep 80% of the bond compared to the previous covariance matrix.
I understand. I'm asking about the actual observations. So say we have one bond. So the number of observations from 2012 to 2014 is going to be 36, right? So 36 return values for that bond between 2012 and 2014. And then in the next box over in 2013 and 2015, there will be 36 more observations for that same bond, the return of that same bond. But 12 of those observations, so the returns from 2015 will be new data, correct?
Yeah, correct.
Correct. Okay, so you have like a full year of your out of sample testing for each of these boxes.
Right. Yeah, that's correct.
Okay, good. So that decreases some of your information leakage. This is good. I'm glad you implemented this. I think this is a good method to use.
Okay. So yeah.
So yeah, and this is the way sample covariance metric estimation and comparison between sample covariance metric and weight covariance metrics.
Yeah, we just apply the same method to the weighted covariance matrix and to compare with the weighted covariance matrix and simple covariance matrix.
And then it is obvious that the weights covariance metric is much more
I think it's
smaller.
Yeah, the MAE is kind of smaller than the simple covariance matrix. If we compare with the P+1 here, there's only 2.85, but in previous one we have 5.6. So
okay, so these values on this next table, all of these, correct me if I'm wrong, are all of these results from the weighted covariance matrix?
no, in this column, the covariance matrix is the weighted covariance matrix, but in this column is just a simple covariance matrix.
Oh, okay, I got it now.
Yeah, and this is MAE. Because when we do the weighted covariance matrix compared to the simple covariance matrix, they also has some distance between each other, right? So we also calculate MAE between the weighted covariance matrix and a simple covariance matrix at the same time period.
This might just be me, but this table's kind of confusing. I think I would rather see two tables, one with the results of the sample covariance matrix and one with the results of the weighted covariance matrix.
We will revise this table. So
yeah,
we will revise.
Yeah.
It might just be me, but if my previous experience is accurate, then the stakeholders in the meeting will also be confused by this. Once you explained it, I understand what's going on, but I think it would be easier for me to understand quickly if there were just two tables.
Yeah, we understand. Yeah, we understand that. Totally understand. So we will revise that for sure.
Great.
Yeah. And the result is that.
Just a question. What's the weighting scheme that you used? What's the weighting scheme you used?
We just use the method from the paper we got from you. There's a paper introduced the weighted covariance matrix. I'm sorry.
What is it? The shrink, it's like a 0.94.
Yeah, 0.94.
Yeah, 0.94.
Should we mention that on the?
Oh, okay, sure.
Should
I think if you just put something, just like a tiny text box that says the weight
Okay, we will add that to the slide.
I'm happy that you were able to implement that. That's good work team.
So the result is that the way sample covariance metric is much better than the sample covariance metric.
Okay, so back to that slide. So those bullet points, you can probably get rid of them. So,
this is a Jeff, but yeah, we will figure it out. Yeah, no worry about that. I will fix that.
Okay.
Yeah.
Just wanted to make sure that this is the slide where you're going to want to.
No. Definitely not. Yeah, definitely not.
Okay, good job.
Yeah. So the next step. I was like, I need to make sure about what that means that the rest of the project looks like. Is that we need to mention the the whole project or just the visualization or something?
So I would just mention that you're going to keep refining the testing of the sample and weighted covariance matrix estimation methods, and then you're going to try to get into some factor-based and shrinkage-based estimators.
Okay, I understand.
I think that's enough.
Okay.
When you talk about the deliverables that you'll be providing, just talk about the final presentation, the code that you'll be giving us for each of the methods that you implement. And then, I can't remember, was the other deliverable a written report or was it a poster? Whichever one it says on the initial presentation, just mention that too.
You said a written report, one of the deliverables?
Yeah, I don't, off the top of my head, I can't remember if this project, if the final deliverable was a written report or if it was a poster, but whichever one it is, just mention that on the slide too.
I think we will write a formal paper about our project.
Okay, great. Yeah, that's good. I would prefer that to the poster, so if you were gonna do that anyway, that would be great.
Okay.
Okay, so if we want us to do the poster, then we will do the poster.
No, just one or the other. So the written report sounds good to me.
Okay, sure, yeah.
So anything more that we should add, Brody, at the top of your head?
Nothing that I can think of. I think this is a good presentation, especially for the midpoint where there are going to be a lot of people who aren't as familiar with this project. So you're going to really want to focus on explaining what you've been doing and why you've been doing it. And I think you did a good job of that in the first section. Maybe, like I said, the results slide where you showed the weighted covariance matrix alongside the sample covariance matrix. It was a little bit unclear what you were showing me. So maybe just tighten up those slides. Once you explained it, I thought it was a really good idea. It's a really good method for testing these estimation methods. It's just the table is a little bit hard to follow.
Okay, yeah, we will redo the table. Yeah, we will revise the table.
And Brody, last week, I think 2 weeks ago, you mentioned something about our bond selection not being evenly distributed. If you recall, what was your point on that?
Not being evenly distributed.
Our point metric system.
It's hard for me to recall. It may have been something along the lines of you have a lot of bonds that are being scored like in the 2 to 3 range, but you're selecting an equal number of bonds from each bucket.
Okay.
But I'm not as concerned about that. As long as you have a consistent method for selecting bonds, I think that's good enough. Like I said, this is going to be my main focus, and I'll get you feedback by tomorrow on this slide, want them to get sidetracked by trying to understand this part of your project that isn't as important as your results.
Okay. Can we send you the list of changes that we made before the meeting so that you can give us an additional feedback?
Yeah, send me anything, everything, whatever you want, and I'll be happy to look through it.
All right.
And I was going to mention that if you guys want to have another call before the midpoint next Thursday, I'm open to that. You just have to let me know. It's totally up to you. If you don't think we need one, if you don't want to come to campus and hold the call, it's fine. But I just want to leave that option open.
Okay, we will discuss that.
But yeah, I think this is a really good job. Just a few things that I'll send you feedback on to tighten up. But this is good. I think you're on track to have a nice midpoint presentation, and with the shrinkage estimation stuff coming after the midpoint, I'm pretty excited with where this project is headed. So good work, guys.
All right. Thank you.
Sure.
Any more questions for me? Do you have any questions about like the structure of the midpoint or anything like that?
Oh yeah, the structure of the midpoint. How is that will be?
So it'll be the same type of thing where I'll send out a WebEx invitation and then just pass over the presenter tool to whoever has the slides. The only difference will be that there'll be a couple more people in the room with me. There might be a couple more people calling in, so make sure to talk loud and clear. And like I said, your professor will either call in or I don't know, he might just come be in the room with you guys. I think he can call in.
Yeah, he's gonna call it. Yeah.
But yeah, we usually plan on maybe 45 minutes for the presentation and then 15 minutes or so for questions. And I think from the presentation today, I think you're well within that time frame.
45 minutes.
Usually,
Okay.
Yeah, and if it's shorter than that, that's okay. Anywhere between 30 and 45 minutes is perfect. Yeah, I think that's about it. It's basically the same as these weekly updates, except a little bit more formal and to a few more people who aren't as familiar with your project. So those are the things to remember. Is these people who are going to be there they won't know as much about the project as I do. So you're going to want to be really clear when you explain things, and just to be like almost overly descriptive of your results, so people know exactly what you're showing them and why you're showing them that. But I think you're already doing a pretty nice job of that. But I think with just a couple improvements and maybe another practice run, it'll be great.
Okay.
Okay. Who else?
Anything else?
I think I will send you an email to explain how I calculate the MAE in very detail, and maybe you, if you have time, please give me some feedback about that.
Yeah, and if you do that, I will also try to maybe put together a visual based on some things that we do here. That might give you like a template for how to display those kind of results.
Okay. Okay, sure.
But yeah, I really like the method. So,
okay. Yeah. Yeah, I will include the method I use to in the email to make everything clear.
Okay, great. And remember to email me the R package that the two R packages you're working with.
Sure. Yeah.
For the shrinkage estimation.
Okay, sure.
Okay, great.
Yeah.
Are we set then? We good?
Yep. Yeah, we're good. Any questions,
All right.
guys?
Thanks, everybody, and have a good weekend. I'll get you some feedback tomorrow on the slide deck, and then if you want to send over the methodology for this testing, I'll get some feedback over the weekend or on Monday, and then let me know next week if you want to hold another call. Again, it's totally up to you, but just let me know.
Okay.
Sure.
Sure.